Hello viewers, in my previous video I have done up to 16 of chapter 9 and today I am going to start from number 17. Here the question is, from a window 15 meter high above the ground in a street, the angles of elevation and depression of the top and foot of another house on the opposite side of the street are 30 degree and 45 degree respectively. Show that the height of the opposite house is 23.66 and here it is given √3 equals to 1.73. Suppose this is the position of the window which is 15 meter from the ground level. So this height is 15 meter. As given in the question, from a window 15 meter high above the ground, suppose this is the position of the window which is 15 meter above the ground. In a street, the angles of elevation and depression of the top and foot of another house. Suppose this is another house. If you see the top, this will be the angle of elevation and this will be the angle of depression are 30 degree and 45 degree. So this angle is given as 30 degree and this one is given as 45 degree respectively. Show that the height of the opposite house, that means this house, 23.66 meter. Let DC be the house where D represents the window. D represents the window which is 15 meter high above the ground. Clear? This is the first part. From a window 15 meter high above the ground. So this is the house. This is the position of the window. So here DC be the house and D represents the window which is 15 meter high above the ground. Now here AB is the another building. So we can write AB be the another house on the opposite side of the street. DE perpendicular to AB is drawn. Here angle ADE is given as 30 degrees. Angle BDE is given as 45 degrees. And we have to prove height of AB is 23.66 meter. So to show AB equals to 23.66 meter. Here DEBC is a rectangle because this part is parallel to this part is parallel to this part, and this angle is 90 degree. We can directly write here DEBC is a rectangle. So this part DC and EB will be equal. So we can write here DC equals to EB, both equals to 15 meter. Okay, as this part is 15, this part, that is EB, also will be 15. Now we'll start from this triangle DEB. We can write in right triangle DEB. Since we have to relate this side and this side, so we can use tan theta. So here tan 45 degree equals to BE by DE. We know tan theta relates perpendicular and base. In this triangle, this is 90 degree. So this will be the perpendicular, this will be the base. So BE by DE. Tan 45, we know the tan 45 value is 1. What is BE? It is 15, because already we have mentioned here BE is 15. So it will be 15 by DE So if I cross multiply, I am going to get DE equals to 15 meter. Let it be equation number 1. Okay, first part is I think clear. Now we are going to use the upper triangle, that is DEA. As we know DE, we can calculate AE. So we have to relate AE and DE. So here also I am going to use tan 30. So in triangle, in right triangle, here triangle is DEA, DEA, tan of 30 degree will be, here tan 30 will be AE by DE. We can write here AE by DE. We know tan 30's value is 1 by root 3 equals to AE is not known, and DE already from the equation number 1 we got it is 15. We can write here 15, we can write using 1. If I cross multiply, I am going to get 15 equals to root 3 AE. That means AE equals to 15 divided by root 3. Now if I rationalize, I am going to get 15 root 3, and here root 3 into root 3. Now root 3 into root 3 we know 3. It will be 15 root 3 by 3. 3 5 ja 15. So it will be 5 root 3. Now what's the value of root 3? It is given in the question 1.73. So 5 into 1.73. So if I multiply, I am going to get 8.65 meters. We have to calculate AB. And we know in the figure AB is AE plus EB. AB equals to AE plus EB. We know AE is 8.65 plus EB equals to 15. If I add, I am going to get 23.65 meters. If in the question it is given root 3 equals to 1.732, then instead of this you write 1.732. In that case you are going to get 23.66. I hope this sum is clear. Let me do the next part, that is 17, second part. From a window 60 meter high above the ground in a house in a street, the angles of elevation and depression of the top and foot of another house on the opposite side of the street are 60 degree and 45 degree respectively. Show that the height of the opposite house is 60, 1 plus root 3 meters. So this sum is almost same as previous sum. Here ED is the house, where E represents the window which is 60 meter high. From this window, if we view another house, then angle of elevation is 60 degree here and angle of depression will be 45 degree. So here you have to write, let ED be the house where E represents the window which is 60 meter high above the ground. AC be the another house on the opposite side of the street. So this is the street and this is the opposite house. Here AEB equal to 60 degree, BEC equals to 45 degree. This is 60, so this also will be 60, because you can write here, because EBCD is a rectangle, and since B is not mentioned, here you can write EB perpendicular to AC is drawn. What we are to prove, that height of the opposite house, that is AC, equal to 60, 1 plus root 3 meter. Now, in the smaller triangle, in this triangle EBC, this part is 60. So we can use tan theta here. Tan 45 will be BC by BE. So here tan 45 is BC by EB, because this is the perpendicular, this is the base. And if you want to relate these two, we have to use tan theta. That's why I have used tan theta here. So tan 45 is BC by EB. Tan 45 value is 1, 60 by EB. So if I cross multiply, I am going to get EB equals to 60 meter. So this part we got 60. Now we are going to consider the upper triangle, that is ABE. In triangle ABE, tan 60 will be AB by EB. Just see, in this triangle, this is the base and this is the perpendicular. So tan 60 will be AB by EB. So tan 60 AB by EB. Tan 60's value is root 3. AB is not known and EB already we have calculated 60. So if I cross multiply, I am going to get AB equal to 60 root 3. Now we want the height AC. What is AC? AB plus BC. So we can write AC equals to AB plus BC. We got BC equal to 60 and AB equal to 60 root 3. If I take 60 common, I am going to get 1 plus root 3. Therefore, height of the opposite house is 60, 1 plus root 3 meters. I hope this sum is also clear. Now I'll do the next sum, that is question number 18. As observed from the top of a lighthouse 100 meter above sea level, the angle of depression of ship sailing directly towards it changes from 30 degree to 60 degree. Determine the distance traveled by the ship during the period of observation, and here in the question it is given root 3 equals to 1.73. Let AB be the lighthouse whose height is 100 meter. Suppose C and D be the position of the ship at two instances. So you have to write like this: let AB be the lighthouse and C and D be the position of the ship at two instances. Here it is given this angle is 30 degree and this angle is 60 degree. So angle XAD equals to 30 and XAC equals to 60 degree. AB equal to 100, it is already I mentioned. What we have to find? We have to find the distance traveled by the ship during this period. That means DC. This distance we have to calculate. I hope this question is clear. Now here, since XA is parallel to DB, so if this angle is 60, this angle also will be 60. These are called alternate interior angles. This is 60, this also will be 60. And here this is given 30 degree, so this angle also will be 30. Fine. Now we will start from the smaller triangle, that is ABC. In right triangle ABC, tan 60 will be AB by BC. Since this distance is to be calculated, from the smaller triangle we will calculate BC, then from the bigger triangle we will calculate BD, then we will subtract. Okay, so let me start with the smaller triangle. In triangle ABC, tan 60 will be AB by BC. Now tan 60's value we know it is root 3. AB, we know AB in the question it is given 100 meter and BC is not known. So if I cross multiply, BC will be 100 by root 3 meter. So let it be equation number 1. Now in the bigger triangle, that is ABD, tan 30 will be AB by BD. So here tan 30 will be AB by BD. Tan 30 is 1 by root 3 equals to AB. And what is BD? BD equals to BC plus CD. So we have written BC plus CD. Now here 1 by root 3 equals to AB is given as 100, BC plus CD. If I cross multiply, I am going to get BC plus CD equals to 100 root 3. Now we know BC equals to 100 by root 3. We can write 100 by root 3 plus CD equals to 100 root 3. So CD equals to 100 root 3 minus 100 by root 3. So CD equals to root 3 LCM. So it will be root 3 into root 3, 3 into 100, 300 minus 100. So CD equals to 200 by root 3. So if I rationalize, I am going to get 200 root 3 by root 3 into root 3. So 200 root 3 and root 3 into root 3, 3. CD is 200 root 3 by 3. 200, if we replace root 3 by 1.732, I told you before also this value depends on the question. So here we are taking 1.732. So 200 into 1.732, if I multiply, I am going to get 346.400 by 3. If I divide, it will be 346.4 by 3 will give you 115.46 meter. Therefore, since CD is 115.46 meter, therefore distance traveled by the ship during the period of observation is 115.46 meters. And that's the answer. From the top of building 60 meter high, the angle of depression of the top and bottom of a tower are observed to be 30 degree and 60 degree. Find the height of the tower. Let me first draw the figure. Suppose this is a building whose height is 60 meter. From here up to this much is 60 meters. Okay, as given in the question, from the top of building 60 meter high, the angle of depression of the top and bottom of a tower. Suppose this is the tower. This is the tower and this is the building. And it is given that the angle of depression of the top and bottom of a tower are observed to be 30 degree and 60 degree. That means from this point, if I join this one and this two, then this angle will be 30 degree and this angle will be 60 degree. Okay, find the height of the tower. That means we have to find the height of this tower. Let me join this one. Here also I can join. Suppose this one is A, this point is B, this point is C, D, E, and suppose this one is X. We have to find the height of the tower, that is ED. So we can write let ED be the tower. Let ED be the tower and AC be the building. Okay, here angle XAE equals to 30 degrees. Angle XAD equals to 60 degree. And AC equals to 60 meters. What we have to find? We have to find the height of this, that is ED. So here you can write to find height of the tower, that is ED. Okay, we have to find the height of this tower, ED. Now in the solution part we can write, since this XA, this line, and EB are parallel, since XA parallel to BE, therefore angle XAE equals to angle AEB, and this also will be 30 degree. This is 30, so this also will be 30. They are alternate interior angles. Okay, again XA parallel to CD, again XA parallel to CD, therefore angle XAD equals to angle ADC, and this will be 60 degrees. This is also similarly alternate interior angles. So this is 60, so this angle also will be 60 degrees. In triangle ACD, we are considering this triangle ACD because this part is known, 60 is known, so we can easily calculate CD. So in triangle ACD, we can write tan of 60 degrees equals to AC by CD. In other sums I told you it is better to start from the smaller triangle, but in this sum, just because AC is known, so we are starting from triangle ACD so that we can calculate CD. So here tan 60 will be AC by CD. Now tan 60 we know value is √3 equals to AC is given in the question 60 and CD is not known. So if I cross multiply, I am going to get CD equals to 60 divided by √3. If I rationalize, I am going to get CD equals to 60 √3 into √3. That means 60 √3 divided by √3 into √3, 3. That means 20 √3. So we got CD equals to 20 √3 meters. Okay, let it be equation number 1. Now from this triangle ACD, we got CD. Now since CD equals to BE, because this is a rectangle, so from this triangle we can calculate AB now. So in right triangle, here also you can write right triangle. In right triangle, now we are considering triangle ABE. So in right triangle ABE, in triangle ABE, tan of 30 will be AB by BE. So we are writing here tan of 30 equals to AB by BE. Now tan 30's value we know it is 1 by root 3 equals to AB is not known, and just because in your just see the figure here BE and CD, because EBCD is a rectangle, so EB equal to CD, so instead of BE we can write it is CD. We can write here since BE equals to CD. Okay, now if I cross multiply, I am going to get CD by root 3 equals to AB. CD already we know CD equals to 20 root 3. So 20 root 3 by root 3 equals to AB. So if I cancel this root 3's, I am going to get AB equals to 20. Let it be equation number 2. Now in this sum we have to calculate this height, that is ED. So ED equals to BC and BC equals to AC minus AB. So we can write here ED equals to now ED equals to BC and BC equals to AC minus AB. As given in the question, AC is 60 and AB we got 20. So it will be 60 minus 20. That means 40 meters. Therefore, we can say height of the tower is, therefore, height of the tower is 40 meters. Tower equals to 40 meters. And that's the answer. I hope this sum is clear. Now I'll do the next sum, that is question number 20. In question number 20 it is given, two men are on opposite sides of a tower. They measure the angles of elevation of the top of the tower as 30 degree and 45 degree respectively. If the height of the tower is 50 meters, find the distance between two men. As given in the question, let AB be the tower whose height is 50 meters, C and D be two men. Okay, now here AB equals to 50 meters given in the question, angle ACB is 30 degree and angle ADB is 45 degree. Now what we have to find in this sum, we have to find the distance between two men. That means this is the position of one man, this is the position of the second man. We have to calculate this distance, that is CD. Okay, now in right triangle ABC, in this right angle triangle, here this is 30 degree, this part is 50, so BC can be calculated. And since it is a relation between perpendicular and base, so we are using tan theta. So here tan 30 will be AB by BC. So from this triangle we are calculating BC, and from this triangle we will calculate BD, then we will add these two. Okay, now in this triangle ABC, tan 30 is AB by BC. Now tan 30 is 1 by root 3. AB as given in the question it is 50 and here it is BC. If I cross multiply, I am going to get BC into 1 BC equals to 50 root 3. Let it be equation number 1. Now in the other right triangle, that is ABD, this angle is 45 degree. So tan 45 will be AB by BD. Just see in this triangle, this is perpendicular, this is base. So tan 45 will be AB by BD. Now tan 45 value we know it is 1. AB is 50 given in the question and BD is not known. So if I cross multiply, I am going to get BD into 1 BD equals to 50 meter. Okay, now we have to find the distance between C and D. So CD will be BC plus BD. So here we can write CD equals to BC plus BD. We got BC as 50 root 3 and BD 50. So 50 root 3 plus 50. If I take 50 common, I am left with root 3 plus 1. Now as given in the question, root 3 is 1.732. So we got this line 50 into 1.732 plus 1. Now 1.732 plus 1, it will give you 2 into 732. And if I multiply, I am going to get 136.6 meter. So distance between two men will be 136.6 meter. And that's the required answer. I hope this one is clear. A very simple sum. What we have done, from this triangle, we have calculated BC, and from this triangle we got BD. Then we have added BD and BC to get the required answer. In question number 21, it is given the angle of elevation of the top of a hill from the foot of a tower is 60 degree, and the angle of elevation of the top of the tower from the foot of the hill is 30 degree. If the tower is 50 meter high, what is the height of the hill? Now let me first draw the figure, then I will do the sum. As given in the question, the angle of elevation of the top of a hill from the foot of a tower is 60 degree. Suppose this one is hill and this is the tower. Okay, and it is given that angle of elevation of the top of the hill, this is the top of the hill, from the foot of the tower. Since this is the tower, this is the foot. So if I join these two, then this angle is given as 60 degree. Clear? Again it is given the angle of elevation of the top of the tower, this is the top of the tower, from the foot of the hill, this angle is 30 degree. That means if I join these two, this angle is given as 30 degree. It is also given if the tower is 50 meter high, this height is 50 meter, we are to find the height of the hill. I hope the question is clear. Here this is the hill, this is the tower. When we see the top of the hill from the base of the tower, angle is 60 degree, and when we observe the top of the tower from the foot of the hill, angle of elevation is 30 degree. This height is 50 meter, that means height of the tower is 50 meter. We are to find the height of the hill. Let me name this one as, suppose this one is A, this one is B, this one is C, and this one is D. Let AB be the hill and CD be the tower. Okay, here it is mentioned that CD equals to 50 meter, CD equals to 50 meter, angle ACB equals to 60 degree, and angle DBC equals to 30 degrees. Clear? This is 50, angle ACB is 60, and DBC is 30 degree. What we are to find? We are to find the height of the hill. So we can write to find height of the hill, height of the hill, that is AB, we have to calculate. Okay, as in this triangle, this CD is given, that is 50 meter is given, so we can easily calculate BC, and once we got BC, this value can be used in the bigger triangle to find the height of AB. So first of all, we will consider the triangle DCB. So in the solution part, you write in right triangle DCB, tan of 30 will be CD by BC. Now tan 30, we know the value is 1 by root 3 equals to CD is 50 by BC. So if I cross multiply, I am going to get BC equals to 50 root 3 meter. Let it be equation number 1. In right triangle ABC, tan of 60 degree, tan 60 will be AB by BC. So we can write here AB by BC. Tan 60's value is root 3. AB we don't know, so we just write AB by BC, and BC is 50 root 3. So here we are writing 50 root 3. You can write here using 1. Okay, now if I cross multiply, I am going to get 50 root 3 into root 3. That means 50 into 3 equals to AB. AB equals to 150 meter. Therefore, we can write, therefore height equals to 150 meter. And that's the answer. Now let me do question number 22. Here slightly printing mistake is there. It should be a tower subtends an angle alpha at a point A in the plane of its base, and the angle of depression of the foot of the tower at a point h meters high above A is beta. prove that the height of the tower is h tan alpha and cot beta as given in the question. Suppose this is a tower, suppose this is PQ, suppose PQ is a tower, and in the question it is given that a tower subtends an angle alpha at a point A in the plane of its base. So this is the base level. Suppose this point is A, and if I join P and A, I am going to get this angle to be alpha, and the angle of depression of the foot of the tower, this is the foot of the tower, at a point h meters high above A. So if I take another point, suppose this point is B, at a height of h meters, as given in the question, angle of depression of this point is beta. So this angle is beta, and we are to prove that height of the tower, that is PQ, is h tan alpha and cot beta. Let me repeat. Suppose PQ is a tower and A is a point in the plane of its base. Now, as given in the question, this angle is alpha. Now suppose B is a point which is at a height of h meter from A, then angle of depression of the foot of the tower is given as beta. And we have to show height of the tower, that is PQ, equals to h tan alpha cot beta. Let PQ be a tower and A is the observation point. A is the observation point. Okay. B be a point h meters above A. We can let B be a point h meter above A. Here angle PAQ equals to alpha and angle RBQ equals to beta. Okay, PAQ equals to alpha and RBQ equals to beta. We have to show or to prove PQ equals to h tan alpha and cot beta. In the solution part, you can write as RB parallel to QA. So if this angle is beta, this angle also will be beta. So we can write angle BQA equals to angle RBQ equals to beta. We can write alternate interior angles. Now in right triangle BAQ, tan of beta equals to AB by QA, because tan beta will be perpendicular by base, that is AB by AQ. So we can write QA equals to AB by tan beta. So QA equals to AB, as given in the question, it is h by tan beta. So we can write QA equals to h cot. So we can write QA equal to h cot beta. Let it be equation number 1. So from triangle BAQ, we got QA equal to h cot beta. Now we are going to consider PQA in right triangle. In right triangle PQA, tan of alpha. Now here if I use tan alpha in triangle PQA, tan alpha will be PQ by QA. So here you can write PQ by QA. Now if I cross multiply, PQ equals to QA into tan of alpha. Now PQ equals to, what is QA? QA we know h cot beta. So we can write h cot beta, and from here tan alpha we can write using 1. Okay, and what is PQ? PQ is the height of the tower. So this is what we have to prove. We have to prove PQ equals to h tan alpha cot beta. So we got this one, h tan alpha cot beta. Therefore height of the tower, equals to h cot beta tan alpha, hence proved. I hope this sum is clear. And question number 23, you can try it yourself. That's all for today. Take care, bye bye, and wait for the next chapter.